Okay, so in this video we're going to look at central angles measured in degrees. And we're going to start by asking, what is a degree? You probably recall from geometry that there are 180 degrees in a triangle, there are 90 degrees in a right angle, 360 degrees in a circle, but where did that come from? Why are there 360 degrees in a circle? And the answer is actually having to do with astronomy. So if you were a person long ago standing on a mountaintop looking out over the horizon, in every direction you would turn, you would see a curve, and that's because the earth is round. So as you would look all around you, you would turn and see a circular horizon, and the sun would come up and the sun would set, and that would be one day, and then it would repeat another day and another day, and it would do that 360 days in the ancient calendar, such as the Persian calendar, in a year. So that's where the degree comes from. It's 1/360th part of a circle. That was 1 degree for each day on the Persian calendar. So now our modern calendars have 365.3 days because of the leap year. So that 360 days really was just an arbitrary number based on observations of the movement of the sun and the stars. So that is where degrees come from, and that means that the definition of a degree is that 1 degree is 1/360th of a circle. Okay, if I take that circle and I divide it into 4 pieces, each of those pieces is going to be a quadrant of the circle. So there are 360 degrees in the entire circle. If I cut that into 4 quadrants, then I'm starting here at 0 degrees, and 1/4 of the way would be 360 divided by 4, which is 90. And that's where we get 90 degrees in a right angle. Then half the circle would be a straight line through the diameter. That is 180 degrees. Then 3/4 of a circle is 270 degrees. And then 1 rotation around the entire circle brings us back to 360 degrees. Okay, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so starting at 0, moving in a counterclockwise direction, that gives us positive angles. Now, a central angle is an angle whose measure is determined by the terminal side of the angle. So let's look at what that vocabulary is telling us. So here along the positive x-axis, that is my initial side of the angle, or the starting ray of the angle, and we call that the initial side. Okay, then going in the positive direction, which is counterclockwise, I would pass through 90 degrees, 180 degrees. Let's say that I come out here to about 200 degrees. Then that ray in my 3rd quadrant, that is called the terminal side. And it's the terminal side of the angle that determines its measure. Okay, now I need to indicate whether I have a positive or a negative angle, because you can go counterclockwise for a positive angle. You can also rotate clockwise for a negative angle. So this angle that I have here at positive 200 degrees, its terminal side, that angle started at its initial side and then went in the counterclockwise direction and stopped here with its terminal side at 200 degrees. So I have to put this curve here showing the direction that the terminal side moved with respect to the initial side. So that angle is 200 degrees. That's important because I could also rotate in the clockwise direction and I would have a negative angle in that case. So my negative angle would start at the initial side and it would go clockwise to the terminal side. So I need to indicate with that curve from the initial side saying what the direction of movement was. And the vertex of that angle, in order to be in standard position, that vertex must be the origin of the coordinate plane and the center of the circle. So when you have a circle and you draw your coordinate plane through it, the origin is at the center of the circle and the initial side of the angle is along the positive x-axis. Then you can move your angles clockwise or counterclockwise. Counterclockwise movement is a positive angle, clockwise movement is a negative angle, and it's the terminal side that determines the measure of the angle. Okay, so that's what it means to be a central angle in standard position. In example 1, we're asked to sketch each angle showing its initial side, its terminal side, the direction of movement, and determine the quadrant in which the terminal side of the angle lies. So I'm going to start by sketching my initial side. And I want to sketch the terminal side at negative 300 degrees. So if there are 360 degrees in the whole circle, I'm going to rotate clockwise in the negative direction. So I would go past negative 90, negative 180, negative 270, and that would put me about here for my terminal side of negative 300 degrees. Now I have to indicate the direction, and this was a negative angle, so I started at the initial side and I rotated clockwise around the circle to get to the terminal side at negative 300 degrees. And the terminal side is in quadrant 1. Okay, let's try example B. So 195 degrees, my initial side is always along the positive x-axis. Then this would be going counterclockwise because it's a positive angle. So I would go 90, 180, and then another 15 would be 195 degrees. I need to indicate the direction of the rotation, starting from the initial side. Then I rotated in the counterclockwise direction to the terminal side, and that terminal side is lying in quadrant 3. Okay, go ahead and pause the video then and try examples C and D on your own, and when you're ready to check those together, go ahead and resume. Okay, so in example C, we want to find the terminal side of 460 degrees. So we're going to start with the initial side along the positive x-axis, and then the terminal side needs to rotate in the counterclockwise direction because it's a positive angle. So we start here at 0. This is 90, 180, 270, 360, and then another 100 degrees is going to take us past 90 again, and then just 10 degrees further. So this would be the terminal side at 460 degrees. And I have to show the direction of movement, so I started at the initial side. I rotated counterclockwise 1 complete revolution, and then another 100 degrees to reach the terminal side. And that terminal side lies in quadrant 2. Okay, now in example D, our initial side, again, is along the positive x-axis. It's a negative 450 degrees, so we're going to go clockwise. This would be negative 90, negative 180, negative 270, negative 360. Then we need to go another 90. So let's see here, we are at negative 360. We're going to go another 90, gets us to negative 450. So the terminal side is along the negative y-axis, and our direction of movement was in the clockwise direction. We went 1 full rotation around, that was negative 360, then a negative 90 more gets us to the terminal side, located at negative 450 degrees. Okay, and the terminal side lies along a quadrant. So it's not in quadrant 3 or quadrant 4. Instead, we call an angle whose terminal side is on an axis a quadrantal angle. So again, a quadrantal angle has its terminal side along either the x or y axis. Okay, so in problem E, we want to find the measure of each angle over the interval negative 360 non-inclusive to 360 inclusive. So when we look at this angle, we notice the markings here indicate we start at the terminal side and we're rotating counterclockwise, so in the positive direction, 1 full rotation plus this little bit. So that's going to be 1 rotation, which is 360 degrees, plus, and then the little bit here is the blue angle. Then it's another 50 degrees to the positive y-axis, and that would form a right angle. So this blue angle is a complement to the green angle, and that would be 90 minus 50 to find the complement. So this blue angle is 40 degrees, and that's how much further we're going past our 1 revolution. So 360 plus 40 makes this angle 400 degrees. Okay, go ahead and pause the video and try example F on your own, and then when you're ready, you can resume and we'll go over it together. Okay, so in example F, when we look at the initial side and the indication of the direction of movement, this is rotating counterclockwise, so it's a positive angle. It goes 1 full revolution around, which would be 360 degrees. And then we need to add from there another 90 to get to the positive y-axis. And then we see here a marking showing that it's another 75 degrees then to reach the terminal side of the angle. So this angle has a measure that is 360 plus 90 plus 75, or 525 degrees.